Okay, so this is a review video for the topic 4 test coming up. It comes straight from the topic 4 review that I handed out in class. If you don't have that, get it from me the next time you're in class. Hopefully you'll be in class before the exam date. So I'm working out the problems. You can see that I have the problem number right here, so you'll know which one from the review sheet it is. And I'm just going to work straight through them. I'll do a little bit of commentary on how to do them. Mainly, though, I just want you to see how the problem is solved, since we've already done some in class anyway. Some of these same problems we might have even done in class. So this is one of the word problems. Again, on a word problem, don't freak out, don't give up. First of all, you might be able to solve it without really doing any of the official mathematical processes like system of equations. And this is a system of equations problem. So I'm going to have to create two separate equations that allow me to solve for, in this case, it's how many yearbooks must they sell before their business breaks even. So that's the question that I'm answering. I'm going to enlarge this a little bit. Yeah, that's a little bit better. So what's happening is Mike and Kim are starting a business, and they're investing $12,000 in equipment to print yearbooks for schools. So each yearbook is going to cost $5 to print, and they're going to sell them for $15. So right away, I know they make $10 on every yearbook. If it costs $5 to print, then they're going to sell them for $15. They make $10 every yearbook. The problem is they've already spent $12,000 on the equipment, so they're already $12,000 down when it comes to how much money they've made. So they're going to have to print a lot of yearbooks at only a profit of $10 per yearbook in order to make up that $12,000 they've already paid. So I know it's going to be a fairly high number. My first thing to do is to create, hopefully this works. My first thing to do is to create my variable. Variable always comes from the question. Sometimes they both come from the question, but certainly the whatever the question is going to be one of the variables. So I see that how many yearbooks must they sell before their business breaks even? So I need to say, and I'm just going to call it X, is the number of yearbooks sold they need to sell to break even. I'll just write it out. They need to sell, and to break even is kind of important, so I'm going to put that in here. So the number of yearbooks they need to sell to break even. The reason to break even is important is because if you don't know what that means, you can't solve the problem. To break even just means how many yearbooks do they need to sell to where they no longer are minus money. Like right now, they're minus $12,000 before they sell anything because they've already paid $12,000. We want to know how many do they have to sell to get to a point where they're not negative, but they're also not positive. So basically, they've eaten away at that $12,000. So my equation, I know, is going to involve some money. And it's going to involve certainly, it's going to involve two equations. So I know my yearbook cost is going to be 5 times the number of yearbooks I make. So that's going to be a part of one of the equations. 5 times X is going to be a part of one of them. I know that. So I'm going to go ahead and put that in. So 5X is going to be in one equation. And that's going to have to do with the cost of the yearbooks. My other equation, I know 15 times X is going to be in there somewhere. Because that's going to have to do with how many they sell. I'm sorry, with how much money they make. They're making $15 per yearbook. Collecting $15 per yearbook, I should say. So I need to figure out somehow, how do they get it to where the cost equals the sales? I also know part of the cost is $12,000. So this is the cost up here. I know that cost needs to include $12,000. Let me go backwards on that. So 5X plus 12,000. So let me just think about it. if I start with $12,000 and then every time I print a yearbook, it costs me $5 per yearbook. So yes, my top equation looks good. That's my cost. Every time I print a yearbook, it costs me 5. I've already paid. So that's going to equal Y. That's going to equal one of my Y's, I should say. Now, I also know that the money I make is going to equal Y. And the money I make is really just 15x. There's no additional money that I make. So I'm done with that equation. That's just 15x. So Y is the total revenue. So the bottom Y, I should say. So this is the total revenue. Again, remember Y is often going to equal to the total of something. So total revenue. Revenue is the money you make. And then this is the total cost. And I want to know, when is my total revenue equal to my total cost? That is your break-even point. Basically, that's when you've eaten through all of the $12,000. So I just need to set, and again, I can just see that this is also works with substitution. If I plug in this 15x right here for this Y value, it kind of sets the equation up for me as well. So that's what I'm going to do. I'm going to say, all right, well, I know 15x, which is my revenue, needs to equal 5x plus 12,000. And now I just need to solve this. So let me scroll down a little bit. So I solve it by saying subtract 5x to get rid of that. And I'm combining my like terms. That's why I'm doing this little subtraction below the original equation, because I'm moving the like term over to the other side. If they were on the same side of the equal sign, I wouldn't need to do this. I would just add them together. But since they're on opposite sides of the equal sign, that's why I do this little subtract 5x, subtract 5x. So I get 10x, which remember, I told you the number 10 was going to come into play because that's how much they make on every single book. And then now 10x equals 12,000. And I also told you I'm basically trying to figure out how much of this 12,000 is eaten up every time I sell a book and I make $10 per book. So it's kind of looking like my math is working out because I'm dividing by 10, which means x, which is going to be how much I need to sell to break even, is going to be 1,200 or 1,200 books. Now, there would be another way to solve this if you just thought about it. If they made $10 on every book and they need to eat through all of this $12,000, because that's basically how much they're down, you could literally just start multiplying 10 times the number of books until you eventually got to 12,000. I'm still saying. And 10 times 1,200 would equal 12,000. So you could also think about this without really doing the system of equation, kind of like we've done in class, which we may do in class, again, by the time you see this video. All right, so that was my first problem. Done with that one. Second problem on this worksheet. All right, so this is just one of the system of equations problems that you need to know how to solve. I just pulled one off the review. In this case, it looks to me like it's a substitution problem. I don't have the sheet in front of me, but since I have this equation right here where y equals some expression, I can take that expression and plug that negative x plus 9. I could plug all of this in right here for this y right here. All right. So I know that I can use substitution on this. I'm thinking it was probably a substitution question. I'm going to get rid of all of that. And I'm going to go ahead and work the problem out. So I know if y equals negative x plus 9, and I have a 3 up there times y, I just need to change that y value. So negative x plus 9. All I did is I replaced the y value. Nothing else is going to be different. Remember, all you do is you take out the y and you change the y value into whatever it's equal to. So 1/2 times x plus 2. So now, again, nothing changed. All of this is the same over here. all this 3 is the same, the equals is the same. The only thing that changed is that y value became this expression. I just changed it to that, right? So now I just am going to solve it out. So 3 times negative x is negative 3x. 3 times 9, I'm just doing the distributive property, is positive 27. Now I have just the rest of the equation, negative 1/2 x plus 2. Nothing changed over there. And so now I can't do anything on either side of the equation because I can't combine an x term and a constant and a number. And that's what I have on both sides. So I can't combine anything on either separate side of the equal sign. So I need to move terms. So I'm going to take the lowest coefficient, which in this case is the negative 3, and I'm going to move that over to the other side of the equal sign. So plus 3x, we'll move that over. Do the opposite, which means I got to be plus 3x here. That's going to give me, and you could change this if you wanted to a decimal, and it should be fine. I'll grade it correctly since that's still the same answer. If it was multiple choice, then you might have to flip it back to a fraction at the end. So this gives me 2.5 x here. So I canceled those out. Those became 0. So now my new equation, I may not have enough room. I can always slide that stuff down. My new equation is, so I still have the 27, so I'm bringing the 27 down. Didn't do anything with that, so that just stays in there. Equals 2.5 x plus 2. So now I need to move the numbers away from the 27. I'm sorry, away from the x. I always leave division for last. So I start with the term over here, the 2, and I subtract that. So if I leave division for last, that means I got to take care of this 2 first. So if I subtract 2 there, I subtract 2 there, which gives me 25 equals 2.5 x. So now my last step is I need to divide by 2.5. Again, this would be fine in a calculator to do is 2.5. So 25 divided by 2.5 is my final step. And let me slide stuff down a little bit. So I divide 25 by 2.5. Well, that's a tricky one to do. I'm gonna have to get a calculator out for that. I'm going to write it, the answer as a fraction when I do it. So 25 divided by 2.5 gives me 10. Oh, that should have been an easy one. 2.5. All right, so I get x. Oops, go back to my marker. X equals 10. I am not done though. Remember, we have 2 variables in this, a y and an x. Y equals negative x plus 9. So I need to take that and solve for that. I'm remembering. So if y equals negative x plus 9, y equals negative x plus 9. I know x is 10, so y is just going to equal negative. I still have to have the negative sign in there, and then I put the 10 in to replace the x. Nothing else changes. So therefore, I can see pretty quickly that y is just going to equal negative 1. All right. All right, so now I need to rearrange some space here. So let's drag all of this stuff way down. That didn't work. So let's drag this way down, drag this way down, drag it down even farther. Oh shoot, I forgot I had those. All right, so now drag this one way down. Oh, actually, you know what? I don't really need that much room to do this other one. All right, so now let's look at the graphing question, the first graphing question. So 14, we kind of did this one in class, but I just wanted to do it again with the tools on this smart notebook. So I have here, oh, get rid of that. There we go. So I have here a graph. They're both in slope-intercept form. So the key is you should recognize this and you should realize, okay, well, I'm going to start from my B value here and my B value here. And then I'm going to use the rise over the run, which is the rate of change, which is my 2 and my -3 to create the lines. So let me get rid of that so you can see. So my +1 is going to be 1 value. That's good enough. Go to the top. That's good enough. So from my +1, I need to go up 1 and over 1 there. So that's actually perfectly put on that dot, so I'm not going to do any more there. Now I just draw my line to connect them, which is a lot easier using this drawing tool. So I go through here. I'm going to make that a little bit better line. It's not perfect. So again, it's not perfect. So let's see if we can. Don't do that. There, that's pretty good right there. It's not going through everything I want. Here, I'm going to do it one more time. Yeah, that's pretty perfect there. All right, so there's one of my lines. I'm even going to change that one to, doesn't really matter, I guess. I'll change it to red. Now I need to do my other line. I need to start with -1. That's the y-intercept on the other one. So we'll do this one in green, I guess. So there's, oh no, I just changed that color. Okay, we'll just do that as green. So my next line I'm going to do as -1. Let me get, there we go. All right, so now I need to change this to red. So -1. All right, so that's pretty good. -1. Then I go, now this is going to be -3 over 1. So my rise is going to be negative. My run is going to be positive. So I would go from the -1 down 3. Oh, I can use this, I guess. So from here, I go down 1, 2, 3, and then over 1. So I would put my dot right here. Which it did not make a red dot for some reason. So let's put a dot right over that. There we go. So red dot. Now, if you understand this, great. If not, don't worry about it. Instead of doing -3 over 1, I could have also done +3 over -1, which means I would have gone up 3 and left 1. So I could have also from this spot gone up 1, 2, 3, and then over 1 to right here. And I'm just going to put another dot there because that's going to help me make a straighter line. So now I'm going to draw my line, connect all of those dots, and we should be good to go. So 1, 2, 3. So we're going to draw from like here through there. That's pretty good, I guess. So let's make that. There we go. Red. I don't love this problem because as you can see, oh, and I didn't really talk about this. So when we have a system of equations and we solve it, we've talked about it in class. Where those two lines cross is going to be the solution. So in this case, two lines cross in one spot, which means there is only one solution. If the two lines were right on top of each other, that's the scenario where it would be an infinite number of solutions that we talked about. If the two lines never crossed, if they were parallel to each other, then there would be no solution because they never cross. If they don't cross, there can't be a solution. We're going to go over that later in this video. All right, so at this point, I'm not sure what they really expect you to do. I'm gonna accept it if you just circle the correct answer. So if you just tell me, well, I know that the solution is right here where these two lines cross. circle that spot because it's really hard to tell exactly what that spot would be. You can see it's in between 0 and -1 for your x value. It's also between 0 and +1 for your y value. I'm not going to make you solve that out to come up with those exact numbers because you're doing that in other problems. So for me, just circle where the two lines cross and tell me that's the answer. All right, so and I should tell you that in class, so you should remember that for class. So now we have to do another graphic problem. This is not in slope-intercept form. We do not have y equals something times x plus some number. So we can't do it the way we just did it with the rise and the run and the y-intercept. This is where you have to plug in numbers and come up with the x and the y-intercept and then just connect them. So I may have to erase some of this since I'm going to run out of space, but I first take this top equation. So I'm doing this top equation first, and I'm going to create that line. I would make x 0, so negative, ooh, I don't know what is happening there. I didn't do that. So I would take negative x, sorry, I would take -4 times 0, and then just plus 3y equals 12, or -12. Now I know this all goes away, so I just get 3y equals 12, or -12, which means I divide by 3, and I divide by 3, and I get y equals -4. Make sure you get the negative. So one of my points is 0, because I made x 0, and y is -4. So I'm going to plot that point. I'm going to do that, and I guess I'll do that in red. I should have put ink in red this one. So 0 is my x, -4 is my y. So I put it about right there. That's one of my points. Now I need to solve for the other y-intercept. I'm sorry, for the other intercept. So instead of making x 0, I'm going to make y 0. So again, I come back up here. I'll just do it. So if I make y 0 this time, that means -4x plus 3 times 0, because I'm making y 0, equals -12. So now that all goes away, and I just have -4x equals -12. I would divide through by -4. I'm going to just mention this. Remember, when you divide through as your last step by a negative, you have to flip the sign if it's an inequality. This is not an inequality, but you're going to see them on the test. I'm just mentioning it right now. You can even think to yourself, oh, well, hey, if this was an inequality, I would have flipped the sign. Or since it's an equal sign, you could really still think about flipping it. It's not going to make anything different. It's still going to look like an equal sign. Just remember that on the test. You have to flip the sign if you divide through by the negative number at the last step. So I now get x equals +3. So my second point, so this point up here was 0, -4. This point down here is going to be 3, 0. Right, so now I'm going to come up here and I'm going to make this point 3, 0 right here with my little pen tool. Right, so I have these 2 points. I'm now going to draw the line for those 2 points. Actually, I'm going to scroll down a little bit. There. So I'm going to draw the line for those 2 points. It would go here. So, oh, move. Shoot. Stop. Get off my. There we go. 2, 3, 1, 2, 4. So that should be pretty good through those 2 points. I think this graph, I'm not real loud about what this graph comes out, but you'll see what I mean in a second. So I'm going to make that line red. Christmas colors. So there's one of my lines. Now I have to do that same process with this second equation. if you take some shortcuts, as long as you're showing some work, like you definitely could probably take a shortcut, and you know that if you make this 0, you're just going to be left with 3y equals negative 12. And if you make this 0, you're just going to be left with negative 4x equals negative 12, just like I have right here and right here. As long as you show me those 2 steps, I'd be fine with that. All right, so now I'm working on the second equation, which is the negative 2x plus 3y. So I'm going to make x 0. So I get negative 2 times 0 x. Well, that's not right, 0. Let's get rid of that. All right, so let's put there 0. Negative 2 times 0 plus 3 times y equals negative 18. So now it all goes away. I'm just left with 3y equals negative 18. Divide by 3. That's my last step when I'm solving equations. Really every time, even if you just divide through by 1. So I get, not too bad. So I get y equals negative 6. So my first point is 0, comma, negative 6. Because I made x 0, and then when I solved it out, y was 6. So now my second equation, my second step is I need to make y equal to 0. So I'm going to say negative 2x plus 3 times y equals negative 18. Negative 2x plus 3 times y is negative 18. Negative 2x plus, well, actually it's not times y because I'm going to make y 0 equals negative 18. So now I'm making y equal to 0 and solving for x. That all goes away. I have negative 2x equals negative 18. I divide through by negative 2. Again, I'm just going to mention it. It's not a factor here, but if I'm dividing by a negative as my last step, if this was an inequality, I would need to flip the sign. So I get x equals positive 9. So in this case, my last point I need is 9, comma 0, since I made y 0 and solved out and got it. So my 2 points to plot in this other line would be 0, comma, negative 6. So 0, negative 6 would be right here. I'm going to do this in green. So 0, negative 6 would be right here. Hard to tell, so I'm going to try to make it a little bit bigger. So 0, negative 6 would be right there. And then my other point was 9, comma 0, which would be over here. Maybe I'm going to this blue. Blue stands out a little bit better, I think. So blue, oh, I didn't mean to make a line. I'm not sure why it did a line. All right, so the blue point right there. And then now I drag down here. I'm just put that in blue instead of green. Now I'm going to use the line tool and connect them, which is going to be a little trickier with this because it almost runs off the page, I think, before they connect. So I'm going to go right through that. All right, there we go. I'll make this one blue, I guess. All right. So now, once again, all you need to show me is you don't have to know the numbers right there, even though this does come out exactly on negative 3 and negative 8, I believe. So negative 3 and negative 8 is the point where they cross. But still, if you just circle and if you just say that you understand that the point where they cross is the solution, I'll be fine with that. It would be negative 3, negative 8 because I did the math the other way. It does come out to be right at that point. All right, so now let's move through. Boy, these are going to take a few minutes to do. I guess I'll go ahead and finish it up, though, even though my dog is crying to go out. So these particular problems, I don't think it tells you this. It's asking you if they have no solution, one solution, or infinite solutions. and they don't tell you how you have to figure that out. So you could set them up to where it is substitution, because you'll notice x equals this whole phrase, or this whole expression. So I could plug in for x right here, I could just plug in negative 4y plus 4. Just take the x out, plug this in. I could also rearrange the formula, and I could move this negative 4y over to the left side. I could just say plus 4y here to cancel it out, and then say plus 4y over here, and then I would get two equations that are nice and organized, and I could do it the elimination way. I'm going to just do it the substitution way because that's the way it's visually set up based on what we have been talking about. So I know if x is equal to negative 4y plus 4, I can just take this bottom equation and say, okay, well, 2 times negative 4y plus 4, all I did is I replaced x, I replaced this, this x right here, I replaced it with this right here. Nothing else is going to change in the equation. So then I would just say plus 8y equals 8. And now I just solve it out. So I'll do the distributive property. So my distributive property is to multiply this times that, and then this times that. So 2 times negative 4y is negative 8y. 2 times 4 is 8. And then that's plus 8y equals 8. And here's where something interesting happens. And we haven't really done this in class prior to this if you happen to watch it. If you'll notice, when I combine like terms, so I have like terms right here, y and y. When I combine those like terms, they cancel out. They go to 0. So I get 0 plus 8 equals 8. So basically, I just get 8 equals 8. We've done this before, and when you get something like that, that's a true statement, that means it is an infinite solution. All right? So that's what an infinite solution would solve out. That's what it would look like if you solved it out. Also, if you go back up to this top equation, let's say I did rearrange it, and I'm just going to do it. Don't worry about it if you don't understand it. If I rearranged it, I would have gotten as my second equation. So I'm going to rearrange this one right here. I would have gotten x plus 4y equals 4. Right? Because I just took this to subtract 4y, and I added it to cancel it here, but then I added it to the left side. So basically I just moved it over by adding it and moving it to the other side. Well, if I multiply through by 2 right here, we talked about equivalent equations. If I multiply every single term here by 2, I get 2x plus 8y equals 4. Well, that's the same equation I have down here. 2x plus 8y equals 8. I'm sorry, 2x plus 8y equals 8. If I multiply this whole thing by 2, every term by 2. That's why we wind up eventually getting 8 equals 8, because they're really the same exact equation. They're equivalent. This equation, x equals negative 4y plus 4, is the exact same equation as this. It's just in a different format. So either way, if you recognize it, that's fine. I don't care how you solve it out. Ultimately, you don't really have to show your work on that, because it's just asking you to say one solution, no solution, or infinite solutions. But if you do solve it out and you get it wrong, I could still give you some points for solving it out. All right, so now back over here, I'm going to do the same thing. I'm going to go through, I'm going to take y, and I'm going to substitute in for y. So 3 times y equals 6x plus 2. So let's put in 6x plus 2. Hopefully I'm going to have enough room for this. And then I'm not going to have enough room for it. Shoot. All right, so let's see if I can fit at least. So again, I'm taking out the y right here, taking that out, and I'm replacing it with this entire expression because I know that's also what y equals. So I'm substituting in. So now I'm going to try to fit this 18x. Nope, I'm not going to make it. Shoot. All right, I'm going to have to. It's easier to do on. So let's solve it out. I'm going to change my pen to blue. Well, actually, here, I'm going to slide this farther down and let's solve it out down here. All right, so the blue marker is for this problem down here. So again, same principle. I'm taking the y out, so 3 times 6x plus 2, and then nothing else changes in the equation, so subtract 18x equals 12. I'll scroll down and go ahead and move this stuff out of the way. So now I just do the distributive property. So 3 times 6x, and then 3 times 2 gives me 18x plus 6. Subtract 18x, which tells me something goofy may be happening, equals 12. Again, 18x subtract 18x just goes to 0. So I get 0 plus 6 equals 12. So I ultimately get 6 equals 12. Well, that is not true. There's no way that will ever be true, which means there's no solution to that problem. If you get something squirrely like that where it just doesn't make sense, I would, first of all, I'd go check your math, make sure you did your math right, which is why I paused. I looked up here and I said, well, 3 times 6x is 18x. I know I did that right. 3 times 2 is 6, so I know I did that right. So that looks good to me. Another way I could check it is I could do the same thing and I could rearrange this. And I could say, okay, well, if I move this 6x term right here, if I subtract 6x to get rid of it on the right side, and I move it over to the left side, I get this equation. Y subtract 6x, oops, stop that. Subtract 6x equals 2. If I multiply this y times 3, I get 3y. If I multiply this negative 6 times 3, I get negative 18x. But if I multiply this 2 by 3, I only get 6, not 12. So they are not the same equation. So this makes sense that I would get 2 lines that are parallel, basically, but they're not right on top of each other, so they'll never intersect. So that means there's no solution. So that makes more sense now, and I feel pretty comfortable about it. All right. That is. All right, so now let's slide down this one. Didn't mean to do that. So let's this one. Actually, I'll just move it over there for now. All right. So now this one is set up a little bit easier to work with. If you'll notice, all the x's are underneath each other, all the y's are underneath each other, the numbers are underneath each other. So I'm going to do elimination, not substitution. But I see that I have an option. I need to get one of these terms to cancel out. I see a problem right now because this term is positive and this term is positive, and this term is negative and this term is negative. So even if I multiply through by the correct number, they're not going to cancel out because they have the same side. So I'm going to have to make it a negative number in order to flip the sign. So I'm just going to multiply this first one times negative 3. So I'm going to multiply that. Actually, yeah, I got to do the first one. I guess I can't really get rid of that 18, unfortunately. I'll do it this way. So this entire expression, or this entire equation, I'm going to multiply by 3. So every single term. So that's going to give me 3x subtract 6y equals 18. Then my other expression is just going to stay. Oh, I'm sorry, negative 3. I need to do it by negative 3. So let's erase that. All right, so let me go back and do that. So negative 3 times all that. So that's going to give me negative 3x and then positive 6y. And then erase this again. And that's going to give me negative 18. Right? So that's my new top equation. I multiplied everything by negative 3. Well, my bottom equation didn't change. I still have 3x subtract 6y equals positive 18. So now I can add these vertically. And if you'll notice, when I add these vertically now, this goes to 0, this goes to 0, and this actually goes to 0. So I am left with 0 equals 0. Don't be freaked out by like that, or don't be freaked out by that. 0 is just a number. So just like when we had 8 equals 8, and we said that was an infinite number of solutions, it's the same thing here. 0 equals 0 is a true statement. That's always going to be true. So that means we're going to have an infinite number of solutions on that. So that would be infinite also. I didn't write infinite on the other one.
Here's a matching video.
Oops.
Before I go, I'd like to know how satisfied you are with that last experience. How would you...
Yeah, that's great. I appreciate it. It's Google. I don't know when I said, hey, Google. But, oh, I just said it, so it's probably coming on right now. Yeah, it sure did. So, anyway, infinite number of solutions there. This would be no solutions here. I'm going to have to abbreviate that. This would be infinite number of solutions here. So that was infinite. Because 8 does equal 8, so that means it's an infinite number of solutions. But you'll also notice too, if I were to multiply through by positive 3 on this particular equation, it would give me the same exact equation as I have right here. So those are just simply equivalent equations. If they're equivalent equations, then that means when you graph them, the line is going to be right on top of each other, which means it's also an infinite solution if you think about it that way. Anytime you can multiply through by a number and you get the exact same equation as the other equation, it's going to be an infinite solution. So 3 times x would have been 3x. 3 times negative 2y would have been negative 6y. 3 times 6 would have been 18. If you can do that before you even do any of the math, you know immediately it's an infinite number of solutions because they're basically the same equation. So let me scroll down. This is the last problem. Let me give us a little bit more room. All right, so 19. He didn't do that. 19. So let's solve this one out. These don't take too long, it looks like. See, this is all nice and neat in columns. I'm going to multiply through by 3. And if I multiply through by 3, the first thing I'm going to check is do I get the same exact equation? Because if I do, then I know it's infinite solutions. Well, if I multiply y by 3, I get 3y. If I multiply negative 5x by 3, I get negative 15x. If I multiply negative 6 by 3, I get negative 18, though. So I do not get the same solution. I can already tell, though, if I get the same numbers over here, but not the same number over here, I'm pretty sure this is going to be that situation where there's no solution. Because eventually, these are both going to cancel out, I'll bet. And I'm going to be left with 0 equals some number on this side, which means there's no solution. That just can't be true. 0 can't equal anything but 0. But let me try it out just to make sure. So again, I'm going to multiply this top equation. I need them to cancel out, so I'm going to have to flip the sign. Because if I just make it positive 3, these are both going to be positive and these are both going to be negative, and nothing's going to cancel out. So I'm going to multiply through by negative 3, which is going to give me negative 3y plus 15x, and then negative 3 times negative 6 is positive 18. So then I just move down here and I say 3y subtract 15x. The bottom equation doesn't change at all. And then equals negative 12. So if you'll notice, these are going to cancel out just like we thought. I get 0 and then 0. You can put plus or minus there. It doesn't really matter. 0 plus 0 is still 0. 0 minus 0 is still 0. 0 subtract 0, that is. And then so 0 is going to equal positive 6 is my final answer. Like I said, that can't happen. 0 cannot equal positive 6. So just like I suspected, that's no solution. And that's the final problem I have on this particular video. So we may have done some of these in class, we may have done others in class, but hopefully that'll help a little bit.